Hello, everyone, and welcome back to another episode of Flutter Original. So, this week I am very excited because we're going to go very, very deep to Dart and Flutter. That's when I'm saying deep, actually, it's really deep. Some of those concepts I even don't know. So, we go deep to compiler, to crazy assembly code, compiled version of Dart, and things like that with Vandad to me. And I'm not going to talk about Vandad because he's here, he's present, and he can introduce himself. Hello, Vandad.
Hi, Majid. Thank you for having me. It's a pleasure, to be honest with you.
Absolutely. So, um, Vandad, so first of all, before we start, introduce yourself a little bit. Let us know who you are because many people doesn't know you.
That's kind of like a philosophical question. Well, yeah, as you said, yeah, my name is Vandad, and I'm a software engineer. I'm a father to three kids. Live in Sweden with my partner, and during the recent years, I've been working with mobile application development for a very long time now. But at a certain point, I realized I need something more, maybe to focus on something like the next step. And a company I was working with, there was a recruiter saying that we should look into Flutter. And this is like about 3 years ago. And I was very skeptical in the beginning, but I picked it up and I was just, glued to it. So that's where I'm right now, just playing with Flutter and doing backend development on the side. So software, basically.
Oh, that's very cool. Vandad, I came to know you maybe, I don't know, 6, 7 months ago. And you've been quite active on LinkedIn, my LinkedIn. Like, I've seen a lot of my connections liked your post. And I remember I contacted you and I said, hey, why aren't are just you are in LinkedIn? And you said, yeah, I'm LinkedIn. No other place. I said, okay, probably you should come to Twitter. And the main
Yeah.
reason was, to be honest, because I was in Twitter mostly, and I want to see those content on Twitter rather than LinkedIn. So,
So
and
that
yeah, and that happened, and you came to Twitter, and that thanks for that. So now we know you on Twitter as well. Flutter community on Twitter is we're very active, to be honest, and you are now part of us, and you are one of the active content creators, let's say, and you've done quite a lot of good stuff. And one of those is a couple. Well, you have tips and tricks for Flutter. You will explain about that. You have going deep to Dart and things like that. So we will get back to that. This is our episode about that one. And you also recently created flashcards, which was very nice and well received by the community, I think. This is also very nice. We will. Do you want to talk about all of this project, by the way?
Yeah, sure. The tips and tricks, just like many other projects that I start, are kind of, they started initially, and I'm not gonna like shy away from saying it. They started as like hobbies and literally just for me. I remember the first tips and tricks I put in on LinkedIn. I can see you're scrolling through the list. The list has grown a lot through the months. But the tips and tricks, I remember the first one that I posted, it was literally me being shocked at how good Flutter was. I was like, "Oh my god, you can do this with Flutter." And then people were like, "Oh my god." I was like, "Oh, what? Is it just me or are like other people interested?" And it seemed like a lot of the things that I was finding out were actually really interesting for other people that maybe learn this way. They listen to other people and they basically consume that information. So you filter out the bad stuff and then you put out the good stuff. So I found out that it's not only a learning experience for me, but I'm also like have a lot of friends that are learning at the same time with me. So it kind of felt like that those moments when you're in a gym and there are lots of other people working
Sure.
out next to you, then you get energy from that. So it was really as you say, it's like the Flutter community is very, very active. So a lot of people were giving a lot of good feedback and saying, yeah, we want to learn more about this and that. So to answer your question, the Flutter tips and tricks really just started as a learning project for me. And it's still that. I'm literally learning every day and putting those learning out for other people as well to see. So, and the same thing, to be honest with you, with going deep with Dart is because I had a hobby project a few years ago that I called Swift Weekly, and the idea was to, unfortunately, the idea was to put out content every week, which I didn't have the time for after a while. But in that, I actually started going into the basics of Swift and how the compiler works, and that repository got really popular. Like within a few weeks, there were almost 1,000 stars on it, and people were asking for more content. So I knew that. I always had that in the back of my head that people are kind of interested in going deep with stuff.
Absolutely.
And Flutter is such a high level framework. Is very, very high level. Like it's almost abstract and absurd how easy it is. You know that. Yeah, so sure. It's very easy to forget what is actually happening. Like when I do this function, what's in it? Like, what is Dart doing in here? So I was curious about that. So I was like, okay, let's have a look at that. And then I start putting some findings out, and then people were just going crazy. Like, yeah, I want to know about this too. So it was, again, the same experience.
Yeah,
sure. Just me learning and other people also learning at the same time with me.
It's interesting. Yeah, I've got also a lot of feedback for your content. So, I mean, that's very nice to see that some people in the community, like yourself, you're going deep, you're diving deep to the code and tell us like how it works. Because it's very easy to forget about it in daily basis. Because, you know, as a developer, you're just trying to build what you are told. Yeah. And then you forget about how it works. And it's very nice sometimes to come back or, you know, one step, let's say, back and look at the things from a little bit like around and, you know, have a better overview of how things works. Yeah. And that's the nice things. And that's the reason you are here today. All right. So you're here today to tell us about Dart compiler. And you already are a few steps ahead of us in terms of that. And perhaps one of the best person that I could have found on a Flutter community to talk about it in depth. And that's the reason you're here. And I would like to invite you to share your screen. And I will start my question from there. I know that you prepared some, you know, content from us. Maybe you can start from there. Tell us how we can set up Dart compiler, and, you know, how did you even get that to work? Like you compile and see something over there, very nice output when you put it on the GitHub. So, and things like that. And I have a few questions over there, which I was asked from other people from the community. So we can hopefully cover it together.
So I started looking around. I literally searched online for compile Dart, because I know that Dart is the language that Flutter uses. And then I ended up in this beautiful documentation that talks about, yeah, how do you compile Dart code into different formats. So the compiled code that I'm used to is like if you compile a C++ or C application or a Rust application into your target executable. So it becomes an actual executable that you can then run on its own. So you can, for instance, say, well, yeah, I want to create, as you can see here, you can create an executable for Windows OS, or you can create, for instance, an AOT snapshot. So I was like, okay, let me kind of have a look at what this AOT snapshot is. So this AOT snapshot is kind of like if you think of an executable for Windows that you create with the Dart compiler, it embeds the Dart runtime into the executable so that the executable is self-contained. Does that make any sense? But
Absolutely.
so that you can run the executable as it is on the target or host platform. That's what I've understood from this documentation, and anyone in the community, if I'm saying something wrong, please correct me. And I didn't want that because I want to kind of like see the raw compiled code without the runtime in the compiled code. So I didn't want to bloat the executable with the runtime. And that's when I came across this thing, which is called an AOT snapshot, which is kind of like an intermediate kind of a binary that doesn't include the Dart runtime in it. So, because then you will have to actually, you can't run it as it is. Like it's not going to become an executable. It's actually going to be kind of like an intermediate format, like kind of like an object file. So I thought, okay, maybe this is better because this is going to get me closer to the raw data. I'm not going to see anything that has anything to do with the runtime.
Yeah.
And the good thing about it is that this Dart compile command here is already shipped with Dart. So if you've installed Flutter or Dart separately, which you can do with Brew, I think, on Mac, and I think you can do apt install on Linux as well. And I think you can also install Dart separately on Windows, I think.
Yeah. You can
do
have
that
on all platforms. Yeah.
All right. Okay. So you don't have to have Flutter, right?
Yeah, definitely.
Great. Yeah. So
I mean, Dart is not only for Flutter, right? It's a fully featured language, so you can use it for anything almost.
Yeah, you're completely right. Yeah. So you can install it just as it is. So in terms of installation for the Dart compiler, all you have to do is just to have Dart installed on your system. So if you have Flutter, you already have Dart, so you don't have to worry about that. But if you don't have Flutter, you can install Dart, as you said, then separately. So that's for the compiler. So you don't have to do anything special. And this is literally the command that you have to run in order to compile an AOT snapshot of your Dart code. So if you want, we can maybe have a look at doing that. Or
yes, let's actually take an example. Let's write something in Dart. Usually I pair program with someone, but I think in this case you can do it yourself.
Okay.
I can accompany you when you are coding. So maybe we can just write something and see how it works in practice or in action.
Yeah, sounds good.
And then we can take it from there.
All right, Majid, that sounds good. Let's go. I use Visual Studio Code, but you can use any code editor that you want. As you can see here, I've just created a simple Dart file, which imports Dart.io, and then it uses this exit function in there. And we have a main function that calls exit, just like that. And to compile this into a Dart AOT snapshot, you can literally take this command from here and execute it here. My file is called testing Dart, so I'm just gonna say testing.dart. So that's it. That is all you have to do to get it to compile to an AOT format. Now, what I usually
What is this? Okay, let's actually ask a question here. So when we compile it to an AOT format, that means, what does it mean?
It's kind of like it is an intermediate object that doesn't, it's like a binary file that doesn't know, that the host platform doesn't know how to run. It's literally a set of instructions that, for instance, if I say print here, print, and I say hello world, if you, for instance, had this same function written in Rust and you imported the std, which is already included in the prelude, that you said, okay, I want to std out this string, then when the Rust compiler, for instance, compiles that, then it says, you are compiling a binary for Mac OS, or you're compiling it for Linux, or you're compiling it for Windows. Then I'm gonna, in order to print, I'm gonna call this system function called this XYZ, whatever it is going to be on that platform. So the Rust compiler then takes the code that you write and then interprets everything in it. And then for anything that it needs to call the OS for instance, printing, showing dialog, showing windows, displaying buttons, maybe whatever, then it makes that bridging in your binary. So it says, this is going to go through this function to the OS, and the OS is going to return this value to me. But if you do it, from what I understood, is that if you create an AOT here, then these instructions make absolutely, they kind of make no sense for the host platform, in that the Dart runtime really isn't like included in them. As, I mean, we can have a look at them here. You see, it creates an ahead of time compiled module. It then uses a Dart runtime command to run the AOT module. So you need to use the Dart AOT runtime in order to run this AOT, because the host platform doesn't understand what this is.
I see.
And again, Majid, I could be wrong about many of these details, to be honest with you. I'm doing my best to explain it from what I've understood from the documentations. But this is the best I've understood from looking at the AOT, that it doesn't include the runtime in it. So,
but that kind of makes sense. Well, so okay, let's move forward. So now we have an AOT file. Is this a file that we can read the structure, or is it a file that really doesn't make sense to us?
To be honest with you, this is a binary file, so I don't even think Visual Studio Code can display this. And it says, do you want to open it anyway? Do we dare to do it? Yeah.
No.
Oh, text editor built in. Okay, let's see. Oh, it looks like this.
Yeah, it's a binary.
It's just a binary, yeah. But the thing is that it starts with an elf. So, and an elf is a Linux or a Unix binary kind of. So, but I still don't think that we can execute it.
Yeah, sure.
I mean, we can test. If I said I have execution rights to this, and if I just said testing AOT, yeah, it's just, you see, it doesn't understand what this is. So we can't execute it as it is.
Yeah, definitely. Well, it was in the documentation that we need a runtime to run the Dart runtime.
Exactly.
All right, let's go to the next step. So now we have an AOT file. Then what else?
So to be honest with you, it's really, after you got the AOT file, the next step is just to dig in. So I really like to start, like when I do these going deep with Dart series, I really like to keep it clean, like as clean as possible, so that there is not like a big margin for errors for me and the compiler. So what I really like is literally just start like this. So I'm like, okay, I have a main function and there's an exit code. That's it. But for me to be completely sure that I found the correct main function in the binary, I usually go and change the exit code to something that I can later find in the binary if that makes sense. Because 0 is just such a generic number, I can't really easily find it in the binary when we look at it later.
Yeah.
So I really like to just go with either dead beef, which is a valid hex code 32-bit integer.
Yeah.
And not for, I mean, no offense to any cows, but it's just a, it's just a magic number that you can easily find, if that makes sense.
Yeah. 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 Sure.
So I usually just put an exit code like that. So we can then compile it like this. All right. And what I do then, Majid, is I use this assembler, which works really well on Mac OS, and it is called Hopper disassembler. And this is in no way any like advertisement for them, but they're doing a good job. Just
Yeah. Okay.
in case they see this. This is a native application in Mac that you run. Do you have to purchase a license for it? I think there may be a trial for it as well, but
I see.
what I usually do then is I go here and I will get my current directory, which is this one, and then I go to Hopper, disassembler, and then I just say File, Open, and then I go to that directory, and then I open the AOT.
Mm-hmm.
And I leave it as it is. It understood that it's an ELF, so I press OK. And it does an analysis and creates the object graphs and everything in the application, because even though it's a disassembler, but it still has a lot of intelligence in understanding the relation between the different procedures and how they
I see.
are bound together, kind of. And yeah, this is basically where the magic happens. At least for me. I mean, this is exciting stuff for me because it gets you very, very close to what the compiler has done for you in the AOT. And you can literally just start typing here, and you can just say main, and you will see 2 instances of main. And I know which one is mine because I see this.
Yeah, sure.
So the way I start looking at it is, I mean, the Hopper helps a lot because you can also have a look at like a pseudocode for it, if that makes sense. So you can kind of look at it as if like you're looking at a C kind of function.
Yeah, sure.
In that it says, this is a function. It has an int return type. And it takes all of these arguments, 5 arguments, and like puts them in these different registers. And like immediately the thing I see here is that, it converted my 32-bit integer to a 64-bit integer.
I see.
So this is all like the magic stuff that we don't see when we work with Flutter and Dart. We just create an integer, but all of a sudden it just becomes a 64-bit integer, even though I didn't make it a 64-bit integer.
Yeah.
So, and you can see literally here what it is doing is that it is like putting that value that I created, it's putting it into a 64-bit general purpose register, as we call it. It is called an RAX. And then here it's setting up the stack. So it's just nothing important. And then here it just calls another system function, if you can see.
Of course.
So this is interesting for me because like exit is a function. Literally, we may not think of it as a function, but it is a function. So you can actually click on this and you can go to that exit. I think it's a command click or something. I don't play so much with this. Oh, here. Until you actually get to the like the pseudocode for exit. So, but usually I don't look at the pseudocode so much. I try to look mainly at the assembly code to see, okay, what is happening here.
I see.
So really, this is like the simplest example of looking at an AOT for, just looking at inside of an AOT for a simple Dart application, Dart code.
Yeah. That is interesting. Do you want to take us to an example? Like, do you want to show us an example of a valid use case? Well, now we have an exit and we can analyze this code with this software, and that's great. But I really want to know, like, when you want to read like a comparison, let's say you had a final and const comparison in Dart. I really want to know
Yeah.
like how you thought about it when you compile it, you read it. Just take us to the journey that you already have gone. So just let us know how you started it, how you ended up, how you made that comparison, how everything
Yeah,
technically.
definitely, Majid. Yeah, sounds good. Um, for me, I mean, the reason I wrote that article, which got very heated discussions on Twitter, was, I mean, it got criticism and it got some good,
Sure.
like, points as well from different people. One of the people that I admired a lot who commented on that was, I will actually show you. I think going deep. His name is Vyacheslav Egorov, and I hope that I'm pronouncing his name correctly. But he is now helping a lot, actually. If I can find, I sent a pull request that he helped here. This is Vyacheslav, and from what I understand, Vyacheslav is leading the just-in-time and AOT compilation efforts at Google for Dart.
I see.
He saw the articles that I published for Going Deep with Dart, and he found a lot of inaccuracies in them. So he was like, "Yeah, you didn't do this wrong. You didn't do this right. This is all wrong." And he was like really putting his time into helping me, and that's what I really love about the Flutter community here.
Yeah, for sure.
It's unbelievable. I mean, that he took time out of his life to make sure that these are correct. It was a huge blessing. So thanks to him, seriously. So, but to go back to your question, Majid, I wrote this article about const over final because I was personally curious. What is the difference? Why const? Why final? And it's so easy just to jump over it and be like, yeah, well, it's this one's a final, that one's a const, and not really know why. So I was like, yeah, I kind of want to know. And what better way to know than to actually go into the code, into the the assembled code to see what the compiler does.
Absolutely.
So it's been a while since I looked at this code, but I remember, like, if you look at this particular example, we can actually do this right now and go into our little code here, which it takes two constant values and then it prints their values and then it prints the result of adding them together.
Okay.
And if you looked at this, you may feel like, okay, well, okay, it's going to print that one and it's going to print this one and it's going to, in memory, add this one to that one and then print the result of that. And it's not a surprise that it's not really that's not really how the Dart compiler treats these values. We can have a look at it together, actually. So let me close this one and say open the same AOT. Let's find our main function again. And this is actually how it works, Majid. It's very interesting. We can actually maybe, what do you think, Majid? Should we first look at the assembly code, or do you want to maybe look at the pseudocode?
Yeah, let's do the pseudocode maybe.
Let's do the pseudocode. Okay. So this is very interesting. As you can see, there are 3 calls to this print function, exactly as we saw in here, 3 prints.
Yeah.
So there's nothing magical happening there. We say 3 times print, Dart says 3 times print. So then where does it get its values from? As you can see, the first one, the value of that dead beef that we put in value one.
Yeah, fair value one. Yes.
Yeah. You can see the Dart compiler decides, okay, I'm going to put it in a general purpose register here, and then I'm going to call this and pass that as the last argument. We don't have to worry about all of these, to be honest with you. This is how the Dart compiler sets up the stack. Mm-hmm. So it's passing that to the print. And then the next one, it says, okay, the next item is feed, and I'm going to print that. And it passes it directly here. Okay?
Yeah.
But the next call is very interesting for me, because if we take, let's take our calculator up here, and I'm going to say dead beef, and I'm going to plus it with feed. And you can see that this value is here. Do you see?
Yep.
So this is the result of adding those two values together. And that's what you see here. So the Dart compiler didn't at all say that, okay, during runtime, I'm going to add those two values together and then print it. Instead, it did it during compile time. So as you were waiting for the Dart compiler to do its job, or if you were, for instance, in Flutter doing a hot reload or anything like that, then all of this is going to happen in the background.
Yeah, sure.
So this was like, okay, this was interesting for me. Like, yeah, it kind of makes sense. There are constants, like the idea of a constant is very important, at least for me, that it's not just an idea that it's a constant. It is a compile time constant, in that the compiler understands this value not to change at all.
Yeah.
Like, not to change at all. I mean, literally not even internally change, because all of these are classes, right? Like pretty much everything, as we say in Flutter or Dart, is a class. And a class can change internally. Like it can, even though you create, for instance, a final value of an instance of a class, the class internally can change, but your variable is still final. So to answer your question for me, I mean, you asked like, where did this come from? And it literally came from that I want to understand what is the difference between final and constant. And for me, this was like the first point that, okay, constant means constant for the compiler. It is not going to change during compile time. Mm-hmm. So that was literally the first example. And then, you can look at the assembly code as well, and you can follow this code, like even to the exits. But I usually don't print the internals of these functions, because they're kind of like, as you can see, they're pre-compiled functions. And I don't think there's any point in going into, now you may think differently, Majid, but I don't see any point in going to actual implementation of a print function. It could get really complicated.
So, yeah, sure. I mean, even by now it's complicated. So, well.
But I think we're doing well. I think we're going through it quite smoothly.
Yeah, sure. You're doing well. I'm listening.
But Majid, please let me know if I'm going too fast or if I'm just saying gibberish.
That's perfect, and it makes sense. So it's pretty much like the things that you're showing. It's somehow expected. If anyone has already like had any experience with compiling any type of language to assembly, they would see probably the same thing. So because some of these concepts are very similar in between languages, right? So many languages does the same. There might be in a high level, an abstraction layer, like different syntax. Yeah. When they compile down, it's pretty much similar things.
Yeah.
But it's interesting to see, in fact, as you said, I want you to ask you a question, and so now, can we just change those const to final and then compile it again and take a look at the assembly code and see actually what was the difference?
Yeah, we can actually change it. This is a good experiment. I don't even know if I actually did the exact same experiment that you're mentioning. I just looked at the code and then I can see I changed one of them to final. But let's do it
Yeah.
the way you say, Magic. I like that better. Let's just change both of them to final and see what happens. So this is new to me as well, as you can see, because I didn't do that experiment in this
Yeah,
example.
that's good.
Let's have a look. I'm gonna then I'm gonna close this one, and then I'll open the same AOT now that is recompiled, and then we go look at it for the main function. Okay. That's very interesting. That is completely different.
Mm-hmm.
Whoa.
Yeah.
Do you see?
And
Magic?
way more actually.
It's a lot more code now. A lot more code.
And I imagine
Wow.
that before even null safety, how much was like, maybe a lot of other things to make sure it's not null, it's null, or, things like that. So,
Yeah, it is very interesting. Actually, the one that you're mentioning, Majid, is a great topic to go more deep into. Null safety, how the compiler does that.
there was a great article by Dart team about that, and they explained how null safety can reduce so much of your code
Yeah.
and also optimize your code. And now we're talking about these code assembly pseudocode in this application, and now it makes sense way more.
Yeah.
So maybe in another session we should bring up these and show like the difference between null safety and not null safe language. So
Yeah.
sorry, like code. So then we can compare it.
Yeah, that's great.
But
I'm curious about that as well, Majid.
yeah, but there is actually a very, very good article and very long one right after they announced null safety. So into a stable. So there was a very good article. I will put the link into the show notes or comment below so people can go and read it.
Sounds good.
This is very interesting. That's very interesting actual experiment right now. Thanks to you to taking us to the diving with me to the depths of the ocean, let's say, where we need to have some mask probably to breathe. So it's quite hard to understand this type of code for sure. It's not a
It is.
type of it's not a things that we do every day for sure.
No.
But it's interesting to learn and interesting to understand. And thanks to you that you opened up this window towards us, and then we can go and dive even more and understand more. We're looking forward to more articles and more comparison from you for sure.
Yes, and thank you, Majid.
You're welcome. You're welcome. Do you wanna give us maybe a tip or tricks or something here related to this? Maybe coding, like compiling and whatever you're doing here. If anyone wants to experiment the same things, have you faced any type of issue or anything that maybe you can mention and some people can take an advice from you and they can just maybe bypass that error or I don't know, whatever.
To be honest with you, the best tip I can give is to, if you're interested in this kind of like going deep to like how the compiler works, the best thing is to get yourself a good disassembler. I mean, that is gonna make life a lot easier for you if you can have a disassembler that actually has, for me, a graphical user interface is important, because then I can literally go through the code, click around and see the stack. I can even debug this code if I want to. So it may not sound maybe like a tip, but the best advice I can give is to get a good disassembler. And I don't have any, I mean, I have no sponsors. I think for Mac, for me, Hopper has worked very well. I don't know if Hopper is available for other platforms. I wouldn't be surprised if it was available for Linux. I would be surprised if it was available for Windows. But I don't know. I just know that Hopper internally uses Python a lot, and Python is available everywhere pretty much. So maybe
Sure.
Hopper is also available. So that's the first tip. And then the second tip is just to take your time and ask on Twitter. For me, Vyacheslav has helped a lot. And find Vyacheslav on Twitter and ask your questions. This guy is a golden guy. I mean, he puts so much time and effort into answering questions.
Yeah, sure.
So get a hold of Vyacheslav, see if you can borrow some of his time. It's worth it.
Absolutely.
It's really helpful.
I hope in one show I can invite him and we can even go deeper, let's say.
Yeah.
Maybe together with you, and then we can go deeper and talk about how things works down there. You know, still we are touching surface, even though we are going deep. Still, it's surface.
Absolutely. I mean, I was thinking that I'm going deep, but this guy is on a whole other level. So,
yeah, sure.
Absolutely, Majid. Yeah, I could learn a lot from him, definitely.
All right, very good. So at the end, I want to also introduce one book from one of the, folks from Dart team, an engineer in Dart team who has written a great book about interpreters. And I think that would be a great example for many people if they want to learn about interpreters. So Robert Nystrom, he is an engineer in Dart team, and he is actually doing a lot of good things. I think one of the guy behind null safety for sure. So if I show his face, probably he's familiar with many of the Dart and Flutter programmers. He has written this amazing book, and I have not read that yet. But it's on my to-do list. I'm definitely going through it this year, by end of the year. This is going to probably show you more about interpreters, compilers, and probably other things. It's just funny that because he put a lot of effort behind the book, and it's free, by the way. You can read it on the web, but I think we need to support him. We need to buy something from him. So yes, that was the last thing I wanted to tell you. And with that said, then I have to say thank you, Vandad, for joining me, and really appreciate your time. I think we really enjoyed this session together. I hope you enjoyed as well as I did. Do you have anything to say for the last words?
Well, no, I just want to give you a huge thanks, honestly, because as you said in the beginning, I wasn't in Twitter, and you introduced me there, and you gave me a great introduction.
Sure.
And on the first day, I got about 480 followers.
Sure.
I'm very thankful for your time as well, and for you to introduce me to the Flutter community.
It's a pleasure. That's my job, to introduce awesome people to awesome communities. So for sure.
Thank you, Majid.
Then have a great day.
Thank you, Majid. You too.